just like I did before, I'm going to get u to the 3/2 over 3/2. Okay? All I'm telling you is I'm not going to rewrite all of that. Isn't all of this letting you stuff, isn't it going to get to that anyhow? Okay? But now, because I don't have any limits, right? And now I have don't you have to go back to X? Everybody agree? Everybody agree? But now,
Should the X total be 3/2?
Yeah, to the 3/2.
yeah, it sure should. Thank you. It should be a 3 right there. Thank you. Everybody agree? Okay. Now, I is equal to the integral from -1 to 1 of 2/3. Oh, I'm sorry. No intervals. Now I is equal to 2/3 times x cubed plus 1 to the 3/2. So do you follow what I did? Here's what I did. I stripped the limits off of it, didn't I? And the reason I stripped the limits off of it was I didn't want to have to bother with changing the limits of integration. So I just worked the same problem without limits. And I went through and found the answer. And now I'm going to substitute those limits back into the answer that I found. And by the way, that's the way I work these. I don't fool with changing those limits of integration, because y'all know how I make errors in arithmetic. That's one more chance for me to make a mistake in arithmetic, is what that is. So now, don't I have 2/3 times -1 cubed plus 1 minus 2/3 times 0 cubed
1 cubed.
times 1 cubed, right? Times minus 1 cubed plus 1. Didn't I just substitute in like we normally did? Everybody agree? And don't I get 2/3 times 2?
That should be to the 3/2.
To the 3/2.
Ah.
That's fine.
Did all the parentheses they did for
That's still 2, isn't it?
Wait, no, raise your 1 to the
Outside
3/2.
You have to raise those things to the 3/2.
Oh, yes. still one.
No, the parentheses.
2/3 times, and I need the 3 halves right there,
Yeah.
times minus 1 plus 1 to the 3 halves. Everybody agree? But that's 0, so I'm through. And now am I not back to 2/3 times 2 to the 3 halves, which is 4/3 times the square root of 2. So I've given you 2 ways to do it. One of them, you have to change, the minute you change to U, the minute you change to U, the minute you change to U, you've got to change those 2 limits. I didn't want to fool with changing those 2 limits, so I worked the indefinite integral problem, and then I put it back in and just substituted the limits in. Okay? This is page 345. Number 2. Don't you like these? Don't you like those? And this is I. And I'm going to say the heck with the limits. And I'm going to say consider I1 equal to the same problem without the limits. Look at Daniel, Glad. Daniel was looking on his card. What'd you find?
Oh, I thought, cause the derivative of the cosecant is the cotangent times the cosecant, but there's a square up there.
Yeah, but keep looking. You're doing it, the reason I'm picking on you is you did exactly the right thing.
This card's for Scal 1.
Yeah, well, look what, see what the derivative of the cotangent is.
Negative cosecant squared x.
Now look at our problem.
You get the cotangent times itself. Well, no, because the derivative. I've got myself confused over there.
That's okay, but at least you know, you get an idea, you know you gotta do something with it, right? The reason I pointed you out is you were doing the right thing. You gotta look on your card and say how those 2 related, huh? And so what I'm going to do is I'm going to say, let U be equal to cotangent theta. This is rule 6 stuff, right? If nothing else works, try something and hope you get lucky. Well, you're not getting lucky because Daniel knew to look on his card, right? That's not luck. Okay? Then du, according to Daniel's card, is minus cosecant squared theta d theta. Is it not? Do we agree? So then isn't minus du equal to cosecant squared theta d theta? Is that right? So now isn't I1 equal to the integral of u du with a minus out front? And that minus came from right there, didn't it? Let me stop and let you look at it and point out that this is a real good time to ask the question. Ed,
I would have worked differently.
what would you have done?
Well, cotangent theta is equal to cosine theta over sine
Yeah.
theta. And
Yeah.
you get
Now
cosine-
we're talking. That's the way I would have done it.
Cosine theta over sine cubed theta be theta and let your u be the sine theta.
Now we're talking. That's the way I would have done it. I just didn't want to carry them too fast. That's what I'd have done exactly. Who had me for trig? Remember I said my little mind doesn't work in terms of secant, cosecant, and cotangent? So what do? I change it to something else, huh? And that's what Dr. Thomas is saying. He does them the same way I did. But this one was so obvious, and I saw Daniel looking at his card, we could just do it straightforward. Okay? Everybody agree? But I think this is equal to minus 1/2 u, I'll go ahead and write it, minus 1/2 times u squared du, du, plus c. Do you agree? Don't you add one to the exponent and divide by the new exponent? But I think that's equal then minus 1/2 times cotangent theta squared plus c. Isn't that what you let u be? Everybody agree? So now I go back and I say I is equal to minus 1/2 times cotangent squared theta plus c, because I am now going to say from pi over 4 to pi over 2. Does everybody see what I'm doing? And what that did is that kept us from having to change the limits of integration, didn't it? So now I have minus 1/2, and I'm going to put it out front. Minus 1/2 times the cotangent squared of pi over 2 minus the cotangent squared of pi over 4. Is that okay? Everybody okay with that? But you know what I know what the tangent of pi over 4 is. Do you? It's 1. If you put it in your calculator, pi over 4 is the same as 45 degrees, so if you put in tangent of 45 degrees, you get 1. If you know the tangent, how do you get the cotangent? Agreed? And the cotangent of pi over 2? Well, remember how I showed you to do it? What are the coordinates of that point? 0 and 1, is that right? So x equals 0, y equals 1. What's tangent theta equal to in terms of x and y? That's right, y over x. Then if the tangent is y over x, then the cotangent is equal to x over y. Do you agree? But don't you know what x and y are? So isn't that equal to 0 over 1? Which is, so I know that this is equal to minus 1/2 times 0 minus 1. Cotangent of pi over 4 is 1, 1 squared is 1, right? Pretty slick, huh? And do you see how I avoided doing the change of variable deal with the limits of integration? Feel free to do that if you want to. Feel free to go in and substitute and change the intervals. But I'm telling you, if you write an integral with the wrong limits on it, it's wrong. Yes.
Can we do it the way understand?
What?
The way,
Can you do it that way?
no, can you show us?
Would you mean would I? Yeah, I got about 2 minutes and I'll do it. Cotangent, cosecant squared. Dr. Thomas's way, we'll give him credit for it, but he stole it from me. What Ed was saying is he doesn't like to mess with cotangent and cosecant any better than I do. So we would say this is equal to cosine theta over sine theta times 1 over sine squared theta d theta. I changed everything to sine and cosine, right? Okay. But now I have the integral of cosine theta over sine cubed theta d theta. Agreed? Okay? But that's equal, but now I'm going to let u be equal to sine theta. 2 ways to do this, right, Ed? I could have let u be sine cubed theta, or I could just let it be equal to sine theta. And either one of those ways would work. Du is going to be equal to cosine theta d theta. Now you see why I picked that way to do it, don't you? So now don't I have Is that right? So now I have the integral of 1 over u cubed du, which is equal to the integral of u to the minus 3 du, which is equal to, add 1 to the exponent, and you get minus 2, and divide by the new exponent, so don't I get u to the minus 2 over minus 2 du? Everybody agree? And then, if this is I1, then I is equal to 1/2 times 1 over u squared from pi over 4 to pi over 2.
-1/2.
Does everybody agree with that? Am I not doing it the same way I did before? But I'm just dealing with sine and cosine, which most of you, like Dr. Thomas and myself, would rather deal with. But I'd better get the right answer. Huh? Or not the right answer, the same answer. I guess they're both, that would make the right answer.
Is it supposed to be a negative? Negative 1/2?
Yes? Thank you, William. What do you think? So now, I got minus 1/2, and I've got then 1 over pi over 2, right? Everybody agree? Square. Oops, square.
Not 1 over the sine of.
You didn't change the
Ah.
variables.
I can go back. Did I? Sorry, I wasn't liking that. I'm in a hurry. That's what happens when I get in a hurry. And this then is equal to minus 1/2 times sine theta to the minus 2 plus 6. And that was plus 6. And I need to slow down. So now I have I equal to minus 1/2 times the sine times 1 over sine squared theta evaluated at pi over 2 and pi over 4. Does that look better? And thank you, all of you. But now this is minus 1/2 times. Isn't this 1 over, and the sine of 90 degrees?
One.
1. So isn't this over 1 squared? Do we agree?
Right.
And this then is plus, minus 1 over the sine squared of pi over 4.
Yeah, 1/2.
Which is
Yeah, square root of 2 over
1, yeah. Isn't it the square root of 2 squared? No. This is 1 over, I'll write It's your way.
Either way.
Do you agree? So this is equal to minus 1/2 times 1 minus 4/2. Is that right? Square root of 2 squared is 2, right? 2 squared is 4, but it's in the bottom. It's in the bottom. Therefore, you invert it. Is that right? Josh, you want to finish it for us? Go ahead. 4 divided by 2. Okay. Go ahead, Josh. You the man.
Negative 1/2 plus. I was just gonna.
Either way. We'll do it Josh's way. Negative 1/2 plus.
1. And then that's equal to negative 1/2, or 1/2.
There you go. Everybody agree? Is that what we got before? I hope it is. See you Friday. What did I do, Ed?
Got real, real.
Oh, leave it on.